If you want to compare more than 2 groups with the t-test, you could use ANOVA, or often you could use linear regression. But if you use ANOVA, the name of the function in R is AOV. So here we put our ANOVA into an object A, and then we write AOV, and then dose, which is the continuous variable we would like to study, and then over the variable we would like to look at. And in this case, we would like to look at C1A, and we need to convert this to a factor to make this possible. And then we put in data equals D. And here is the result we get. As factor C1A, there is a significant effect of this on the warfarin dose. If we want to know a little bit more, we could write model.tables, and then for A, and then ask for the means in the citation marks. Then we get this table of means, and the grand mean, which is the mean dose in all patients. And then here as factor, those with 0 mutations in the C1A, they have a dose of 44.6 milligrams a week in the mean. And those with 1 have 33.7, and then we have those who have 2 mutations who have only 22.4 milligrams a week. And then in this second line, it shows how many patients we have in each group. We have 527 patients with 0 mutations and so on. And I actually don't know why it's presented like this with this decimal point. Here's an example of a two-way ANOVA where we have 2 predictors with an interaction. We put this in the object A, we write AOV, and then dose over as factor C1.A star 6, and then comma, and then data equals D. And then if you look at summary A, it will look like this. We have this as factor C1A. We can see that there is a significant difference. We look at 6, there is also a significant difference. And then we look at this interaction term as factor and 6. And this one is also statistically significant, and this means that the effect of this C1 genotype, that it differs between the sexes. If you want to know which groups that differ and so on, you could use Tukey HSD for doing a post hoc analysis. And if we look at this model.tables A, and then the means for this two-way ANOVA, we get this result, the grand mean, and then we get the results of C1A as factors and how many patients we have in each group. We can see on the gender here, and how many females we have and how many males. And then we also get this interaction term where you could see that the mean dose of warfarin in females with 0 mutations is 40.6, and with male is 46.9, and so on. If you have non-normally distributed data, you could use KruskalWallis rank sum test as a non-parametric alternative to a one-way ANOVA. So in this case, you use the function kruskal.test. And you write like this: kruskal.test dose, then over as factor C1.A, and then data D. And then you get this result. You can see that there is a significant difference between these groups.